Okay students, now we'll study third point from this chapter, electromagnetic waves. That is, what are electromagnetic waves and what is the source of electromagnetic waves. So from name itself we can understand electromagnetic waves are the waves which are having electric as well as magnetic field inside them. So these waves consist of both, or they are having both electric as well as magnetic field. And in the electromagnetic waves, electric and magnetic field are perpendicular to each other, and they are also perpendicular to the direction of propagation of wave. What is direction of propagation? That is the direction in which that wave propagates or wave travels. So electric and magnetic fields both are perpendicular to each other, as well as they are perpendicular to what? Direction of propagation of that electromagnetic wave. So electromagnetic wave consists of what? Both electric as well as magnetic field. The simple example of the electromagnetic wave, it is what? Light or visible light. Visible light is a electromagnetic wave. Okay. Speed of the electromagnetic wave in the air or vacuum, it is always equal to the speed of the light. That is 3 multiplied by 10 raised to 8 meter per second. It is the speed of the electromagnetic wave in the air or vacuum. Okay. Now we'll study what is the source of the electromagnetic wave. So source of the electromagnetic wave, it is accelerating charge. Accelerating charge example is what? Oscillating charge. That is, if we consider one charge, if it is oscillating, oscillatory motion is what? To and from motion about the mean position. So if it is a oscillating charge, each charge is having what? Its own electric field surrounding it. So when charge oscillates, its electric field changes. So that changing electric field, it is producing what? Electric field. Changing electric field, it is producing changing magnetic field. And again changing magnetic field in turn produces what? Changing electric field. Again changing electric field produces the changing magnetic field, and so on. Like that way, this wave or these waves propagates from one point to another point. Okay. So understood how electromagnetic waves propagates from one point to another point. That is, when charge oscillates, the electric field is changing. Due to that changing electric field, it is producing what? Changing magnetic field. Changing magnetic field in turn produces what? Again changing electric field, and again that changing electric field produces changing magnetic field, and so on. It continues. So like that way, electromagnetic waves travel or propagate from one point to other point. Now see, if we consider like this x, y and z axis, which are mutually perpendicular to each other. Okay. Now our wave is traveling towards the z axis, or it is traveling along or propagating along the z axis. Now firstly, oscillating charge, it is producing what? Varying electric field. So here it is varying electric field. So its its magnitude at every point, it is different. So it is a changing electric field. Okay. This changing electric field is producing what? Changing magnetic field. Again, changing electric field, it is producing again what? Changing magnetic field. While drawing this, these arrows are parallel to what? X-axis. While showing the electric field, these arrows are parallel to X-axis, because direction of the electric field, it is in the direction of X-axis. And while drawing this, show this arrow parallel to the y-axis, because the direction of the magnetic field, it is parallel to the y-axis. And our wave, that is electromagnetic wave, it is propagating along what? Z-axis. So understood how electromagnetic waves propagates from one point to other point. They propagates in the form of what? Changing electric and magnetic field. So both electric and magnetic fields are present inside the electromagnetic wave, and these two fields are perpendicular to each other, as well as they are perpendicular to what? Direction of propagation of wave. And due to this reason, electromagnetic waves are known as transverse in nature. What is mean by transverse nature? That is, electric and magnetic field are perpendicular to each other, as well as they are perpendicular to the direction of the propagation of the wave. It is known as the transverse nature. So electromagnetic waves are also known as a nature of the electromagnetic waves is a transverse. Understood? So understood what are electromagnetic waves, what is the source of the electromagnetic waves, and how they propagate from one point to other point. Okay, thank you.